To determine the total number of zeros of a polynomial function, we can apply the fundamental theorem of algebra, which is a big hitter. The fundamental theorem of algebra contains numbers in the complex number system. So now we're looking at numbers that are imaginary, such as bi. The fundamental theorem of algebra says that if you have a leading degree n, that means there has to be exactly n zeros, and that includes complex numbers. Also tagged with that is the conjugate root theorem, which states that if a plus bi is a zero, then its conjugate a minus bi is also a zero. You can also see it in this form where you have an f of x, and let's say that the leading degree is n. That means that these factors multiplied out in linear form are going to be n number of factors. Let's take a look at doing two problems. I did some work on here because, as you can see, that it does require some effort. But the first one's pretty basic. It says write a polynomial function of at least degree with real coefficients in standard form. Well, we'll forget about the standard form, but it says that the zeros are these three zeros, but along with those zeros, you also have 4 minus I, because the conjugate has to be a zero as well. So your f of x would equal, again, you're looking at, these are the zeros, so it's got to be x plus 4, x minus 1, and then 4 plus I, and 4 minus I. Now, the mistake with that is that you're really looking at subtracting off those numbers. So it's x minus negative 4 is x plus 4, x minus 1, which is the same, and then it's going to be x minus 4 plus I, and you got to be really careful when you're doing that, and then x minus the other factor, which is 4 minus I, or its conjugate, which means that your f of x is going to now equal x minus 4 minus I and x minus 4 plus I. Let's take a look at the second problem that says that you should rewrite the f of p of x in terms of linear factorization, which means put it in linear factors, including the complex ones. Now, it's giving you a p of x, and it's also giving you an x is equal to 5, I is a 0. That means that negative 5i is also a 0 because it's the conjugate. And 5i doesn't really help me when I want to divide out. So what I want to do is, first of all, go ahead and find the product of the two conjugates. So x minus 5, x minus 5i, x plus 5i, when you multiply that out, you get x squared plus 25. Now you're talking about real numbers. I can't use the synthetic division because of this square. I have to only apply it where it's to the first power. And when I do long division here, I should end up with a remainder of 0. If you didn't, then there's a mistake. Once you have that information, then you're looking at taking this quotient and figuring out, can you factor? And you can. If you couldn't factor, then you could use the quadratic formula and find out the two irrational numbers or imaginary numbers. But at this point, you're now able to write down the p of x with all the work that you've done. Your p of x is equal to x minus 1, x plus 9, and then the two factors up above. Notice there are 4 factors. 4 factors means that the leading coefficient should be a 4 as well. And that is what the fundamental theorem of algebra states.